Welcome to VirtualFox Fest 2024. This session is about unit tests with FoxMock, and my name is Christoph Wollenhaupt. So why do I think I'm qualified to give this talk? Well, for one, I'm the author of FoxMock, so that helps, hopefully. But I'm also an international speaker, and have talked about FoxMock and written about FoxMock quite a bit over the past decades, actually. So what are we talking about this time? One thing is we talk about what problems FoxMock solves, because if you don't have a problem, I can't offer you a solution. So we will find a couple of problems. And then we talk about how you use FoxMock in unit tests. And along the line, we will talk about how you can design code to make it more testable, designing for testability. Let's start with why is it so difficult to write proper unit tests in FoxMock? One thing is that FoxMock isn't really suited to create little classes like you can do in C# or even Java. If you create a visual class, you can't even move a method from a subclass into the parent class because you can't edit the parent class while the class is open. Classes are really slow to load, so we tend to write classes that are large, have a lot of features, are interconnected, and that's actually making it quite difficult to test. And then there are all these nagging questions. So, like, why should I test something? Isn't that quite too simple and obvious? I don't really need to test that. And FoxMock uses data. So what about the data? If you look at literature about unit tests, they don't talk about data. They talk about objects, but we have data. We also have lots of interface parts. We don't necessarily, especially in older applications, separate the UI from the business logic, so we can test the user interface. Sometimes we have pressure, so we really need to get the job done, and spending time on unit tests, well, looks like it takes some time, and does take some time initially, but it saves time in the long run. And most of us are using frameworks, so we obviously need to integrate those into our unit tests in some way. So what is a unit test anyway? The definition given by Martin Fowler and Ken Beck in their book Refactoring is unit tests are highly localized. Each test class works within a single package. It tests the interfaces to other packages, but beyond that, it assumes the rest just works. So if we look at what this means is that we have several units. And if we test each unit separately, then we have a unit test. If we combine several units, integrate them, we have an integration test. So this talk and FoxMock is about unit testing. It's not about integration testing. This will become important soon. So let's look at a sample. Usually people use order objects or customer objects. I'm from Germany, and the day that we haven't complained is a day wasted, so we use a complaint business object here. Let's look at a typical implementation that we see. So this is a complaint object. It does have a load method to load a complaint by ID, and because we don't like complaints and want to get rid of them, we also have a delete method. So load is using a connection, it's getting the connection object and then executing a select statement. So over your plane could be ODBC to SQL Server, could be a DBF file in the back. We also do the same thing with the delete method. We get a connection, we execute a delete command and return a status if the record was deleted or not. That's very, very standard stuff. So let's look at get connection. It's not in the code here because there are several implementations that are common. If you look at code that has been written around the 90s, early 2000s, a lot of FoxMock applications use a GeoApp object and have some sort of database connection manager that is managing connections, because SQL Server initially didn't support pooling of connections. So opening a connection was a very expensive operation. We wanted to maintain connections. We needed sometimes more than one connection. So there's the connection manager that gets the connection. And within our application framework, all of this works just fine. The other common approach is creating a separate object. That's when, especially in later applications, when pooling came around, you didn't have to pool your connections yourself. You could just use SQL Connect to SQL Server, and the ODBC manager would pool connections. In this case, we create the connection in the init, and then the get connection is returning the connection object. So let's try to test these. So what would a test look like? What we want to test is the delete method. We want to check if we can actually delete. So if you open a book about unit tests, you pretty much end up with a test like this. Doesn't look like way too complicated. We have a variable for the business object. We create an instance of the object that we want to test. We load a first record, a known record, and then we delete the record and assume it's deleted. However, if you try this and run this in a unit test, you probably run into several issues. Like, depending on how you implement a get connection, GeoApp is not available in a unit test. So you get a GeoApp is not an object method. Or because the connection manager cannot read the configuration, you get a login dialog from ODBC that asks you to enter credentials, which isn't a good thing in a unit test. And even if the test works the first time, it doesn't really work the second time because, well, you deleted the record and you can't load it. Depending on how you implement this, it might be that the second time load doesn't even throw an error message. It just moves to EOF, and then you delete on record number 0 in an empty table. Or maybe load doesn't create the cursor, so the load method or the delete method will display an error dialog that the alias hasn't been found. So there's a lot of things that make this really simple business object and really simple test hard to test. So let's change that. So we now make sure that we have a connection to the database and we insert the record we want to delete. And in order to verify that we actually deleted the correct record, we try to retrieve it after calling our delete method and make sure that the rec count is 0. So that's already adding a lot of code. But it still doesn't fix all of the problems, because while data is handled properly, we still haven't got an GeoApp object, and our configuration isn't loaded. So if it's in an init file or in a registry or hard-coded in somewhere, the configuration isn't available, the connection cannot be established. We still can't run this code outside of the application. So let's fix that. Now, we create our own GeoApp. And because we can't use the real one, we create a custom class test app that has a connection manager, and it has a config object because the connection needs the config object. So we define the connection manager, have the get connection method, which creates an object DB connection. And then because the DB connection needs to access needs to know the database and the username and all of this, we also create a config object with all the configuration settings that the DB connection object is querying. As you can see, compared to the initial test, which was kind of this line here, we now have a page full of code. And now imagine you want to add another test that tests if what happens if the connection fails or if delete fails. So you would suddenly duplicate all of these classes. You would have to find a way to name them. Instead of test app, you have test app test delete, test app test delete 2. And if in a real Fox unit test, the test is part of a test class. So all the other classes that we define have to go at the end of the file. So in reality, you don't have a test delete and then following your test classes. What you really have is you have a dozen, 2 dozen tests followed by a couple of dozen test classes. And at that point, you will probably get frustrated because it's so much work to just test delete, which you believe is working anyway, because why shouldn't it? You have been writing delete commands for like 30 years. So you come to the conclusion that unit test is nothing for database applications. It's something that works in the .NET world or maybe in JavaScript, in the JavaScript world, but it's not working with FoxPro. But that's not necessarily true, because we must be missing something. And that thing we are missing is what a unit test is. Because, as I said, unit tests are highly localized. Each test class works within a single package. It tests the interfaces to other packages. And then the most important part, but beyond that, it assumes the rest just works. What we did in our test initially, or in this test, isn't just if the delete method is working. It's also testing whether the DB connection can read from the config object. It's testing whether the DB connection object can send statements to SQL Server, and it's even testing if SQL Server can actually execute the statement. So what we have here is not a unit test. We are testing things all the way down to the end of the system, to a SQL Server. And what we want is we want to test just this one object, because that's the unit we are testing. And actually, we only want to test the delete method. We don't care about the other things. So testing, we need to find a way to limit the test to what we can test. So we don't want to access SQL Server at all. We don't want to create a record. Initially, this might feel weird because you really want to know that the record is actually deleted. But that's not the point of a unit test. That's not the thing we do now. Of course, it's relevant whether you actually can delete, whether that works, whether the statement is correct. But that's not something we care about right now. Right now, we care about whether the delete method is actually sending a delete statement to the server. And if it behaves correctly, if it encounters different situations. So let's look at another implementation, or an implementation we are going to test now. So this is, again, our complaint business object. And we are using the get connection approach that uses UApp dbcon manager get connection. And we want to write a test. And this time, we are actually using, well, we are using more objects that are not testing the database. So again, we do have a defined class that has a simulated application object. We have a connection manager that returns a connection, but instead of returning the actual connection, we would just return a test connection. And that test connection has an execute method, which takes a command, ignores the command, and just returns 0, which means success. So as the error code, basically. So now the test is simpler because we are only testing delete, but we still have the problem that we have a lot of classes, that it's really hard to create variations of this test. We cannot just test something, a missing connection or loading, if load failed or anything. So that's when you use mock objects. There are a couple of names for that, like some people call them mock objects, fake objects, stub objects, and depending on the author, they also have different definitions for these. I just call them mock objects. Mock objects are objects that behave like the object that we want to use, but they are not actual objects. They don't do anything. They just keep track of whether a method has been called. They just provide methods that are empty, basically. So let's look at how this looks in FoxMock. At first, this code might look a little bit weird because it's using a fluent interface, which is quite common in .NET or JavaScript and many other languages like PHP, but it's not very common in FoxPro. And it's actually, if you look at the technical implementation, it's actually not, we don't have fluent interfaces. This is a simulation. It just pretends to be a fluent interface by internally using access methods and arrays. But let's first talk about what this code does and break it down into pieces. So the first thing is we need a GeoApp object. And we want this to be a new mocked object. So we use mock. Mock, in my case, is my instance of FoxMock. I usually create the mock object in the setup for a test case and then release it in the cleanup of the test case so that I have mock available in all my tests. News indicates that we want to mock a new object. First thing we do is we define, or we say that we need a property called dbConManager. That property is an object. Obviously, it's our connection manager. So we use isObject to indicate that the property we want should return an object, and we create a new mock object that is a connection manager, and specify here for technical reasons that it should be returned as an object. The connection manager object that we are mocking has a method getConnection. GetConnection returns an object. Again, we create a new object, and the object returns has got an execute method, and when you call the execute method, it should return 0. So what you see here is exactly the same code that we've seen in the test before. Instead of having to define several classes, I just used one line of code to define the tests. So back to FoxPro. So using this, the test looks a lot simpler. We define our global object. I always use private in tests instead of public because the visibility down the calling hierarchy is identical, but it automatically goes away when the test finishes, so I don't have any public objects lying around from previous tests or other test cases. Then we just define the dependencies of our business object, what we need, and the original test. So we still have the lines of code that most frameworks have, languages have, and then we just have 4 lines or 5 more lines of code to define the code, and it's all in one test. So if I duplicate this test, I can just copy everything and change what's in there. I don't have to create a new set of classes. I don't have to scroll up and down to find where the object is defined. As you see, this is the original test, which was testing the entire system. And now we have a slightly longer test that is just testing our business object. Everything is inside the test. The relevant line that we are talking about is our definition of the Leo app object, and then this code is being, or this object is being used in two places. One is the get connection object. So this call to Leo app is actually accessing the mocked object, and this property that we defined here is then used here, and the get connection method is called after that. At a later point, the value that we have, the connection object, which is another mock object, this object that we returned here, has an execute method, which is being called here, and whatever you pass as a parameter is completely ignored by the mock object, but it will return true, so ln status 0, so ln status will be 0 after calling this code. Any questions so far?
Just one. Jeff asks, are there any tools for creating acceptance tests for Visual Fox Pro?
There are generic tools for acceptance tests, but I'm not aware of any that is specific for Fox Pro. So, but that would be more than a unit test, so it's not really something we should go into depth right now, but we can talk about this after the session. Okay, so back to the interface. So fluent interface. A fluent interface is not just another way of describing, of writing code. It also has Fox unit. Also has other impacts. So let's look at the test again. So this is an actual unit test that is using FoxMock. So this is Fox using FoxUnit, which is basically the only available unit testing framework for Fox Pro. In our setup procedure, we are making our business class available, and then, which I mentioned before, I create a public mock object, which is an instance of FoxMock, and release it at the end in my teardown. And then we've seen the test. It's just the same test again. So how does Fluent interface help? No, first of all, we talk a little bit about the properties. So the way it works is we define a private variable, could be a local variable or a public variable too. And if we used a traditional approach, we would have something like having a create mock object method, which would return a mock object. And then we would somehow have add property methods or add method methods or configuration methods and do all of this. So this basically would be the same code as this one. It would achieve the same thing. So you might wonder, why should I do this over the other? If you compare the two, it's a little bit less code to write, but saving lines isn't necessarily the best thing to focus on. Like if you have C++, you can write really short code, but it's sometimes not readable. That's different for Fluent interfaces. Let's look at a classic Fox Pro code. And that comes down to how computers work. Computers are managing state and executing commands to change state. So every time a line is executed, you have an initial state, then something happens, and you have a new state. because that's how computer works. That's how we structured languages initially. Tell the computer what to do. And if you want to understand as a human, because you are not a computer, I hope, if you want to understand what this code is doing, you actually have to go through this code line by line. So you look at the use command, and then you look at what is it doing. It's creating a cursor. Then you see that's somehow saving a record number. Why, you don't know, but it's then scanning and scattering and inserting and locating, and in the end, it's browsing. But in order to understand this, you really have to read the code. If you have a lot of experience, you might detect certain patterns in code and then just take a shortcut. But that leads to another source of error, because you might miss some subtle change, subtle difference in the code. So you see it as a certain pattern, but it's actually slightly different. So you don't notice necessarily a bug or something. It's a lot easier if you use an alternative version of that code. And that code is simply select star from Fox user. Both versions do exactly the same. But why is the select statement more easy to understand? Because select or SQL is not describing how you do something, how you get a data, but it's describing the result. What do you need? What should my data set look like? Where should it get data from? You don't care whether how select is actually arriving at the result. The only thing you care is the result should look like what you want, and it should be fast, obviously. So Fluent interfaces are similar in this regard, because they let you instantly see that the property value is 1. Especially with syntax highlighting, and you focus on n value is 1. You don't have to figure out whether n value is being added to a property or to an object, or where it's coming from. You can read this. At least, hopefully, you can read this. So this makes it easier to understand what the requirements are that you are dealing. So let's look at some of the rules that we have. So first of all, we always need a mock object. As I said, I put this into the setup. Then the entire definition of an object has to be on one line. It's one line of code. You can add further properties to this. The second line, or second time you access the object, you are not in definition mode. You are suddenly in using this object and using the mock object. So while along the definition, every property is returning another instance of the mock object, at the time you are here, it's printing 1. So that's what you see. Because technically speaking, this is a collection object, and this isn't a property that doesn't even exist. It's all used by, or all simulated by using this access. So mock has a this access method that intercepts that you want to have a new method, or that you want to call the new method. So behind the scenes, it creates a new object that has a new array. And the new array also has an access property, access method, and that access method is being called when you access, or when the next code is executed, and that the content of the array is always the mock object itself. Sounds complicated. It's confusing in code to read in the FoxMock PRG file, but it makes things look like it's actually Fluent. But technically, this is an array, and this is an array. There are some implications to that, because arrays can have only 1 or 2 indices, and those indices can only be numbers or strings. So in FoxMock, everything is a string. If you, as you've seen in the past sample, if you want to return a numeric value, you have to put in quotes. And if you want to return a string, you actually have to put it into single quotes or double quotes, whatever you prefer, or squared brackets. But you have to basically nest the string in another string. Also, you have to do this on 2 lines. So definition of the object, using the object. You cannot do it in 1 line, because in this line, FoxMock considers itself to be in definition mode. And only if you execute access the object in a different code line, it's switching to mocking or object or execution mode. So this line would actually cause an error message because the object doesn't have an end-value property, and it's not yet in mocking mode. It's still in definition mode. So to summarize, every object has to be defined in a single line. All FoxMock methods receive a single parameter, and that single parameter is always a string. You can add as many properties and names or methods as you want. So you would use property. To add a property, you specify the property name, and then you specify using specify the value. So accessing the helloperson.firstname would return John, helloperson.lastname would return Doe, and the getFullName method would return John Doe. You might look at this and think, wow, that's code duplication. You probably would have expected something like this. It's first name plus last name. But that's not what you should do, because we are in a unit test. We are not in programming mode. We are writing a test that when we want to test the methods, and we know that it has John Doe as the return as a result. In fact, sometimes it's better to actually return different values and not the actual result, like returning A, B, and C in the methods, because this makes sure that you are not actually using the result of the method in a way that's not supposed to be, like trying to separate the first name and the last name by searching for a space and then doing a left or string extract on the result. Because getFullName might actually return different things in different situations, or it might be localized, or it might have different result sets. So by using a completely different value here, you can have an extra layer of security that you are really only using the getFullName method to deal with the full name, and not as some input for a method that it's not supposed to be used for. So to define members, you define a method using the method keyword and returns for the return value, and the property function or keyword to define a property and is for the return value. The only exception is if you have an object, you have to use returns object, and for property you have to use isObject, because objects need some internal extra step. And that's easier to do with using a different syntax. So one of the things that FoxMock allows you to do is, or easier to do, it's open, is we've seen this test, and then we do another test, and it looks very similar. The only difference is execute returns 1 in this case, so it doesn't work. It doesn't load the record. No, that doesn't, sorry. It doesn't delete the record. It's not executing the delete command. Execute fails, indicated by 1. So I can just make a copy, just change that one little character, and then execute the test and see, okay, my delete fail test works. And I can do the same thing with with another test where the getConnection doesn't return an object, it returns null instead. So I can very quickly make copies of my test and test various different scenarios. I don't have to create a whole new set of classes, like another 3 classes, another set of application objects, config objects, connection objects. I just change single values in here to have different scenarios tested. And using the data feature in FoxUnit, you can also define an array here that is, for instance, test no connection data and then try different return values and specify different results. So it makes it very easy to actually come up with scenarios and not having to fear the code that you have to write. So, and if you do this, you actually notice that, no, our code is not working. Because we assume that in our business object, that if we look at the code again, we assume that we get a connection and that load doesn't have a status. So we can't even cancel. We load a record. We don't know if the record's loaded. So we don't even know if the delete method is deleting the correct record or not. It might work on the previous record. So that's something that we can easily fix. So we create another variation. And in this case, we check the status. And if the status is 0, so execute works, only then we assign the ID and then we return true or false for the load method. So having various different variations being available or being able to test them quickly allows us to find errors that we might have not thought we have in our code. Because it looked good before, it was just wrong. So, let me introduce another thing, because what we want to know is what happens if execute works for the initial load statement, but the delete method failed. So far, we only defined execute as a single method, and we always returned 0 or 1. So because we are calling it twice in our business object, once in the load method to load the record, and then in the delete method to delete the record, we had the same return value for both. But sometimes we want to have a different return values based on different conditions. So that's when you use the when keyword in FoxMock. So here in the first you define the default behavior. So when nothing else has been specified, execute will return 0. But if it's being called with this parameter, then it will return 1. And this value has to be identical. It's an exact match, so it even has to be the same casing. But it allows you to specify multiple versions of having the same method return different results or even fail. If you have more than one parameter that you need to call, you can just add a comma and then add as many parameters as you need, up to 21, 22, which is the limit for FoxPro. So, no. So you can define conditional values for methods using when. The syntax is you specify the default actions, and then you can have as many conditions as you want and specify the action for that condition. What should happen when this condition is true? So let's look at various implementations oh, that's good. No, that's not the one of the get connection. Because we also, if we use unit tests on FoxMock, one of the things that FoxMock shows you how testable your code is, how flexible your code is. Because if you have to write a lot of setup code to being able to test, then your code has a lot of dependencies on other objects. And if you have to, the difficulty is to get the connection or the dependencies replaced by mock objects, you also have a lot of hard-coded connections. So there are several ways that FoxPro developers typically implement something like the connection property. A common way is you create the object in the init event. You have a property or connection, you create it once in the init object, and then you might have get connection method returning that object so that in a subclass at certain points you can just override get connection and do it differently if you need to. So that adds some extra flexibility. Another approach that I've seen in projects is you also have a connection, cConnection class property that contains the class name of the connection you want to use. And then you create the object in the init using that class. So in application-specific subclasses of your generic complaint object, you could change that property and everything else would just use that class instead. So it's not hard-coded like in the previous one, but it's configurable. The problem in FoxPro with being able to configure is this is something that the init event is something that differs between visual classes and programmatic classes. In visual classes, you can have the no init settings. You can avoid the init event. With the add object, you can also do the same thing in code. But for visual classes, you cannot pass any parameter to init. It's always, the init is always, has always no parameter. And also gets complicated when you have subclasses of nested objects, of containers that have objects inside, and then subclass them, add a couple of other objects. And then everything happens in a random order, basically. So another possibility to get around this is you define a connection property that is initially null, and then in the init check whether it's null. So in this case, if you have the no init checked and init doesn't happen, you can assign something to the connection property. Or if you have a subclass of this complaint subclass, you would override the init and assign the connection property, and it will not get overwritten by this line. I've also come across this version, which means that you pass a property which is good for testing. And if a connection object has been passed, you use that connection object. And if no connection object has been passed, you create a new DB connection object. The problem is, or the advantage first is that the test becomes even simpler, because instead of setting up the Geo app object and the DB connection manager and the connection object, you just pass in a mocked object directly into the method. You have the create object, instantiate the BizComplaint, and say, and by the way, I need an object that has an execute method that returns a 0. So it's really not a lot of code. With this approach, this is the same as having all these various classes at the end of your test case. But it gets complicated in applications, because the BizComplaint object needs a DB connection object, but maybe the DB connection object needs to read the configuration somewhere, and you need to pass a config object. And the config object needs to have a source like the registry object, which is used to read these things. In other languages, you usually have an IOC container for that inversion of control, where all these objects are created by the container and then passed on in the init automatically. In VFP, this doesn't work because, as I said, for visual controls, you cannot pass things in the init, so that makes it hard. And we also have not a typed language and not any metadata about the types we have, so we cannot automate this concept. For my framework, I therefore settled, or one of the frameworks, I settled on a different approach. I introduced a post-init, which is called after the init. There are some ways to automate this in my code, that the container is automatically calling the post-init of all contained objects if I need. And then I have an evaluate reference method that is part the name of an object, of a property. And in this property, I define what class should be used. So if I put an object in here, it remains an object. If I have a string in there, so if the var type of the property is still a string, it's creating the connection, the object behind the scenes. In a test, this requires that you actually have to call post-init at some point. So you create the object, you mock the connection object directly in your test case. In the actual application, you would just leave it at the default. You call post-init, and then you call load and delete. And then there's a similar case which combines two of the approaches we've seen before, which is we define the connection property, initializing it with null, and in the init we are checking if it's still null, and if not, we create an object. Otherwise, we just return the connection. And this time we are not doing it in the init; we are doing it in the get connection method directly. So this means on the first call, if you didn't specify another object, we will create the object and then we just return that object. It means that we have this extra check every time we call get connection, but that's a very quick thing and it's really nothing we have to worry about performance-wise. Because the biggest problem we have is that init is something we cannot control very well. So everything that we move outside of init makes things easier for us. So those were 6 different approaches how you can configure something like the DB connection. And some of them are easier to test than others. And some of them are more flexible than others. But every one of us has their own choice and their own preference, most likely. Any questions so far?
Nope.
Okay. Let's look at another thing that we want to test. So we have some clever code that decrypts, which is empty because we don't need it. In this case, we want to test whether the logon method really calls the connection object, whether the connect method is called, because that's what logon should be doing at the end. Or whether it errors out because our clever code wasn't as clever as we thought and introduced some bugs. So that's when we can use expectations in FoxMock. Expectations is, well, you expect something to happen. So in this case, we have a database connector, and the database connector has a connection property. And we want to test the database connector's logon method. The connection is something we don't care about. We don't want to access SQL Server actually. We don't want to have a database available. We don't want to have the username configured. We just want to know whether connect actually calls, whether logon actually calls the connect method, passing in the correct name and properties. So we expect that the database name is DB name, and that these things somehow our clever code decodes to SA and SA. By the way, SA is not a good username, and it's certainly not a good password for the system administrator on SQL Server. So because we use the expect keyword here, we tell FoxMock that this method needs to be called at some point. And then we use call to. Call to is actually the same thing as method. We could have used method here because it defines a method. It just reads better expect call to connect instead of expect method connect. And we expect a call specifying these properties or these parameters, and we do not define the default. So if a connect is not called at all, or if connect is called with a different set of parameters, those expectations are not met. And at the end, we call the verify all expectations. And if there's any expectation that has not been met, then we get a exception that is called by Fox unit, and you get basically a red result. So this expectations allows you to ensure that certain things happen and not just that the return value is correct. So we have three things that we do. First of all, we have expect call to. Name means that this method has to be called. If we have a when after that, we specify that it has to be called using this exact set of values. You can have multiple whens to have the method being called multiple times with each set. If it's not being called with one set, we still not meet all expectations. We use mock verify all expectations to verify that the expectations have all been met. And if we decide that something shouldn't happen, we can use mock fail in our definition to say, if you encounter this case, that's a failure. And it's not meeting the expectation at all. So we have the positive case, method has been called, and we can also say this method should never be called. Let's look at a few samples. So let's assume we have a save method. The save method is in our form on our UI component, and it's calling a business object save method. And if that save method in this business object works and returns true, then we end our edit mode and do something like enabling or disabling controls or refreshing something or reloading or closing the form or whatever. And then we want to show a message. If data could not be saved, we want to show a message. And a service broker is another concept you can use. If you have dependencies. So there's the service broker that has services or different objects. It's basically a customizable version of UApp.SomeManager object. So the translation service would provide translations to whatever language you want. We translate that record. And the message services service would provide like a display alert method that would show a message box. So this is the application code. So how do we test it? Now we are getting into mocking definitions that are a lot more complicated. So we define a service broker. So we specify in the control that this control has access to our service broker. We are not using UApp, we are using a property here. So we have the get service method. And when the translation service is requested, we return an object, a new object, and that object has a translate method that returns the text OK. Remember, this is a unit test. It doesn't have to return anything useful. It can just return something. You don't have to actually translate things or write long text. OK is good. It's simple enough. And when the message service is requested, we expect a call to display alert, because what we want to test is the case that save is not working. We don't want to test the case that save is working, because that's what we always assume. We want to test the case that the business object save returns a false. So when display alert is called with the text that our translation service returned, that's what we expect. We want to see a call to display alert having the text OK. Any other service that's being requested is a failure, because that's not something that should happen. So we say for everything else, just fail. This isn't strictly necessary. The test would work without this line, but it's a way to make your test future-proof for future changes, as you will see in a moment. So we also have the BO object, and the business object, has a save method, and for our test case, we want it to return false. And then we use save, call the save method, and verify our expectations. And if the save method, another service is called, or if translate isn't returning OK and display alert isn't being called with OK, then this expectation will fail. So imagine you wrote this code like 10, 20 years ago and then modify it, or have someone else modify it. Right now, we often see that other people are taking over projects. And assume that, that this other developer is adding the text error colon into the display alert because they wanted to make sure that it's an error it's being displayed here. The obvious thing is error is an English word, so it's not translated. If you run this in Canada, it's not showing in French, or it's not showing in Spain if you have a Spanish application, Spanish. But because you tested or expected the same text that translated returned, and so the translate returns OK as a translation for cannot save record, and display alert is called with error colon OK, the expectation is not met, and the fail that we've seen before is kicking in. So this when is not fulfilled, so this fail is executed, and verify all expectations will raise an exception, and your test will be read, indicating that you have to change this result to error colon OK if that's what you want. If you want to show it, if you want to show error for all cases, or to fix this code and move error into the text and update your translation tables. Also, at some point, another developer might want to add some extra services, like a plugin service, so that these methods can be customized. Because we had the get service fail whenever it's called with something else, you will notice that the test suddenly is read after you add this line, because now you have another service in here, so you want to have another test. You either want to modify the existing test, or you have to add another test to test this plugin case. So by having the fail line in there, you future-proof your code to changes that happen in years from now. If you change something, this indicates that you might have to change, or at least review, your tests. We often have something like this. We want to test this and make sure that this code isn't causing error. In FoxMock, there's one problem with try-catch and error handling. Try-catch was introduced later on, and there's some really weird rules on what is being triggered, whether it's the try-catch or whether it's the error handler, depending on whether there's anything in the error handler, even a blank, and whether that's the object that has the try-catch or it's somewhere in the calling hierarchy. So having a try-catch in here, because that's also what FoxUnit is using, means that FoxUnit will not turn your test to red if this line is executed. So you can work around this by defining a GeoApp object and have a log error method, and then say whenever that method is called, it's a test failure. It doesn't matter where in the entire calling hierarchy it's happening. Log error is something that should not be called in this test at all. So if do something actually has an error in the code that you wouldn't see in your unit test, here you would see that log error has been called, and that means that your test failed. Let's look at another thing that you could do that's also pretty common in FoxMock, which is saving the position of a form. When you close the form, you save the position, and when you open the form again, you restore the position. And you want to know if this is working. So we define our Vue app that has a getStorage method. We expect it to be called when we close the form. And we expect it to be called with form.a, or whatever the keyword we had. In this case, we expect it to be called this way. And getStorage returns a storage object that the form can assign values to. So we have an nLeft property and an nTop property. You notice there is no is between. So these properties don't have any values. They are just properties that we can write into. And then we define this object and give an ID. We say this is not just an object, but this object is the storage object. In our test, we do create a form, an actual form. We call the move method, and then we call the release method. What release should do is it should access the getStorage method, get the storage object, and put the properties into that storage object. So verify all expectations does check whether getStorage is called, because that's where we have an expectations. But we also need to check whether we actually have the real values. Do we have 11 in nLeft and 12 in nTop? Or maybe we miswrote code and put the top position in left and the left position in top. So we want to check this. And when you have specified an ID for an object in FoxMock, then you can use this syntax, mock, and the ID of this object to access that mocked object and access the nLeft property and the nTop property and assert that it's 11 or 12. Also, we specify what property we are checking so that we can see in FoxUnit that which of the properties was not stored correctly. Sometimes the named object is useful if we want to have two methods to return the same object. So we might have the case that the method C needs to be called on this object, but we don't care if it's being called on the A object or B object. So it doesn't matter if loservice.a.c is being called or loservice.b.c is called. In both cases, our expectations would be met. So what we do is we define a new object. We set up the expectation that the C method is called, and then we define this as object. So method A is returning the object, and method B is returning the same object. We first define it this way, and then we just say, okay, it returns an object, and this object is the object that we have defined before. You can also add objects yourself, create objects yourself. That's, for instance, necessary if you want to have a collection, because the mock object is a collection itself. It cannot mock a collection. So you can create your own collection. Doesn't have to be the base class, could be your class, and say it's added at the storage object. So your code now can just return that collection. So you say getStorage doesn't return a mocked object. It returns the object that has been stored as using the ID of storage. So it's returning that actual collection object. And then we do the same thing. We create the form, we close the form, and now we can use the item method to actually check whether the left property is 11 or not. So in summary, objects, you can either say as object, which internally uses a string, as everything is a string that's being passed around and uses the collection internally, or you can actually specify a specific name and then refer to that object in other definitions of the same FoxMock instance. This is also useful if you have objects where you can really mock everything, where you have to do something a little bit different. So you can create or define the class in your test as we saw in the very first samples, and then instantiate that object and put it as using the ID, and then refer to that in other mock objects. So you can mix and match objects if you encounter a problem that you cannot handle in FoxMock. Some things are possible in FoxMock that to handle these cases. For instance, suppose we want to mock a command button, and the command button has certain things. So you can pass the name of a class to new. It doesn't have to be always have to be mock.new.something. You can also say mock new command button. And in this case, what FoxMock is doing, it's creating a command button behind the scenes and then adds all your mock method to it. So this command button is then extended by a myfunc function, which returns 1, 2, 3. So if you set the caption, which we haven't defined, but it's part of the command button's base properties, and assign the return value, you can then access that property and have the value returned. So that's useful if you really have to have some of the behavior. Just be aware that you actually have a command button, a live command button. So if you use one of your classes that does something more complex, all of this code is being executed, and it might be executed more than once, because FoxMock behind the scenes is creating various instances of these classes. Another case is, and we have code or situations where we cannot call setFocus, like in a valid event. You cannot call setFocus while you're validating something, or when you call modal forms. So in this case, we have a control, and it's based on a text box, which has a setFocus. And whenever setFocus is being called in a process, we want the test to fail, no matter where in the entire process this is happening. So when we actually call our service that we want to test, and the do method passing in the control, which would be some control on a form usually, and any code somewhere in this whole chain of calls called setFocus, we would notice, and the test would turn red in FoxUnit. Sometimes you cannot just specify the class name. You want something more sophisticated, like if you use one of the Stonefield libraries, you can specify, using this syntax, you can specify the class name, followed by the pipe symbol, and then followed by either a PLG file or VCX file, which is the class library. So this internally translates to a defined class as from command. And then you can extend this, so the about method, the simulated about method, returns the string whatever. So in a summary, extending classes, the syntax is you either specify the class name, or you specify the class followed by the pipe symbol followed by the library. If you've been using an older version of FoxMock, then you might have some features, or might not be aware of some features that have been added later on. So let's look at those within the test code that FoxMock ships with test. Because obviously, I used FoxUnit to test my own code and that I create. So one of the things is you sometimes have is you have a table, and that table has not 2 fields like here, but it has 250 fields, because that's how you designed it or someone else designed it. And then you are tasked with the job to create a mock object for that record, because you have what you want to test is some XML export or JSON export, and you want to make sure that the whole string is being translated. And what you don't really want to do is to have 250 property is that value, property is that value. So what you can do is you can use the scatter method in mock, and what you pass in is the alias, and then you pass in the clause that is added to scatter. So that is, in this case, it's scatter record 1. It could be scatter all like, except, whatever you need. And scatter will add all fields in that table that have not been defined before. So in this case, when we define the object, we test whether C field is test passed over here, which is the value that we specified in the table. We specify not OK for data, but we say in the definition that data is OK, so we test whether data is OK, and that's what actually happens. So you can use scatter to simplify the definition, especially if you don't really care about the values of the data. You just have to have the right type and the right property, because your code is generating JSON, and it's a ton of values. The other issue is sequences. So because sometimes you want a method like test, and the first time it's called, it should return 1, and the second time it's called, it should return 2. So you can use then, so method test returns 1, then return 2, and the first time we call test, the return value is 1. The second time we call test, it's 2, and because we didn't specify a default at the end, the default would be true, because every method that returns and doesn't have a return statement would return true. You also can combine this with when. So we define a method. The default for this method is true, is 3. But when you pass in the true as a parameter, it returns 1, and the second time you pass true, it returns 2. So first time calling it with true, returning 1, then not passing a parameter, so it's false. The return value is 3, and then you call it the second time with true, you get 2 as a result. So that's, for instance, if you have a method that works the first time but should not work a second time, like deleting a record. The first time you can delete a record, it returns true, and the second time it can't delete the record, it returns false. And you can also return several values in a row. So you can say then return 2, and then automatically return 3 on the next call. FoxMock is behind the scenes, especially if we use the base class feature, the feature to have classes, it creates temporary PRG files. So you end up having a lot of temporary files in the temp folder. So the cleanup method is there to allow you to delete all those temporary files that FoxMock has created. You would typically call it in the in a test case in the tear down method. So here you create the mock object, and in tear down you call cleanup, and then you release it, so all the files are gone. It's not a requirement, but your temp folder will grow over time. The other thing is bindable, because it's a simulated object. Every time you access a property, you actually get a different object. By using bindable, you get the same object every time. It's again using a PRG behind the scenes. So in this case, we have a new object, a handler that has a property which is 42, and we expect the call to on event and make it bindable. And then we bind this handler to the paint event of screen, call the paint method, unbind this to clean it up, and then we expect, because we expected it, we expect that screen underscore screen.paint call the on event. So there are lots of things that are not working. For instance, because it's all simulated, we have no object identity. FoxMock is a collection object. So it has a base class property, and that says collection. If you have code somewhere that checks whether an object is a scatter object or not by checking whether there's a base class property or not, those checks in your code would work with a real object, but they would fail on FoxMock. Also, anything that checks for metadata will fail. Bindable objects do have some support, but if you do something like A members or PEM status on the mocked object, you don't get a real result because you are checking the properties in FoxMock, and FoxMock does not have the properties that you created. Also, because we rely on this access, there's no support for with and with. If you do something like with mocked object and then use dot property, with is actually caching that object and reusing the same instance, and we don't know what property you want to access, so it doesn't have that access. The same is true for scatter and gather, because scatter and gather really directly access the object and bypass with this property, and because they need to know what properties are available, you can scatter and mock to create an object that has all the properties, but you cannot use it, for instance, using the additive clause in scatter to add other properties to that. And for the same reason, you have no COM support. You cannot pass a mocked object to a COM server or to _VFP, because that's a COM object too, or use it in a for each loop without using the Fox object clause, because COM relies on being able to access the number of the available properties, and the mocked object doesn't really have properties available. So looking at what you learned today is testing is better than no testing. And you probably wondered where you get FoxMock. Well, it's available in the download section for this conference, but you can also get it on GitHub and on my GitHub account. So that's it for today. Thank you very much and enjoy the conference.